All right, team. I'm going to do the homework video. I'm in a more comfortable situation. Gonna try to crank it out. Just explained everything. So, I'm not going to explain why. If you are just going straight to the homework video, shame on you. I'm not explaining why. All right. We got G equals 2x plus the accumulation of F. I'm just going to not worry about that. And this is the graph of F. G of 2 would be then 4 plus the accumulation from negative 3 to 2 under F. So negative 3 is where I'm starting. 1, 2, 3, 1, 2, 3, 4. It's a 1/2 base 3 height 4, which is 6. This is a 1/2 base of 2 height of 1, 2, 3, 4, which is 4. And then we'll stop there. So 14. G of negative 3. Why am I doing this? I mean, there's a good reason. The slope is down 3 over 2. I'm doing this for a reason, guys. I'm not telling you what the reason is yet, but the reason is no, this is down 2 over 2. The slope is negative 4. Some reason the AP exam sometimes likes to trick you up and not put numbers at whole numbers, not put like points at whole numbers on lines. So being able to adjust and adapt based on a slope is something that like a lot of students have difficulty with. Negative 6 plus the integral from negative 3 to negative 3. Oh, gosh, what? I was thinking we went to negative 4. I'm off. Sinuses. Okay. G prime of 3 equals 2 plus F is G prime. And all y'all who are not watching my homework video, my notes video, I'm not explaining it. You go back and figure it out. And if you're like, oh, whatever, it doesn't matter, it's like, it's going to hurt you in the long run. So G prime is 2 plus F. So G prime of 3 is 2 plus F of 3. F of 3, 1, 2, 3. Yeah, there you go. Done 1, 2, 3, 4 over 2. So this slope is negative 2, which is down 2 over 1. So this is the point 3, negative 2. So I got 2 plus negative 2, which is 0. That's important. G prime of 1 is 2 plus F of 1. What is F of 1? Same thing down 1, 2. This is still the slope of negative 2. So this is going to be the point 1, 2. So that's 2 plus 2, which is 4. Oh, look at that. I'm going to throw this at you. If you think, oh, whatever, I'll just figure it out. No, go watch my video. H of 2 would be the accumulation from negative 3 to 4 of F. Did I find that? Nope. Negative 3 to 1, 2, 3, 4. So this is 2, negative 4. That's negative 4. So that's going to be 6 because I add 6, add 4, subtract 4. What's H prime? Let's say I couldn't accumulate F. Let's say I had to take an antiderivative. The antiderivative of F is big F. What do I do with the antiderivative? Plug in the end, plug in the start. Here's big F at the end, here's big F at the start. Big F of the start is a starting value, it's a number. If I took the derivative of that, which will be the derivative of this, I get, because of the chain rule, regular F of x squared times 2x. It's like I plug in x squared into my function, and I have to multiply by the derivative. So h prime is f of x squared times 2x. H prime of 2, therefore, is f of 4 times 4. F of 4 is negative 4 times 4 is negative 16. Then, find the min value. You're like, oh, 2 is a can. No, you're all wrong. You're not paying attention. Don't watch this video. Go back to the lesson video. Understand why I'm looking for when G prime, which equals 2 plus F, changes sign from negative to positive or an endpoint. Now, it's going to be an endpoint. Why? Because if I shifted everything up 2, this point would get shifted to 0, or if I found when G prime, which is 2 plus F equals 0, that's like F equaling negative 2. I look at F equaling negative 2. I can see it's above that line. It's greater than negative 2 until 3, and then it's less. We have a max at 3. There's no time when it changes sign from negative to positive. If you don't like doing that, your other option to adjust things is to shift everything up 2, which shifts this point to 0. This point goes to negative 2. This point goes to whatever, 6. This point goes to 2. This point goes to 4. So it looks like this. Okay, so really my only 2 candidates are my endpoints, G of negative 5 and G of 4. Wally, what's up? You want to say hi to my students? My son's home from his birthday party. I got an integral. Wait, hold on. What do I have? Buggy, can you turn on some lights, dude?
Sure. Alexa, turn on the back light.
That's pretty cool. Yeah, the videos are here. G of negative 5 equals negative 10 plus the integral from negative 3 to 5 of F. The camera's over here. You can't see it. How's the birthday party, dude? Say hi.
Hi.
Say, I love math.
I love math.
What was the birthday party like?
I forgot. Like a bouncy house and a swimming pool. I sure couldn't go in the swimming pool because he had a cough.
Bomber, did you go to the swimming pool?
Yeah.
Did he have a bathing suit?
Yeah, he wore a bathing suit.
Sick. Bouncy house and swimming pools?
Yeah.
Did you get super hot in the bouncy house and then jump in the pool?
Yeah.
And then got cold from the pool, then jump in the bouncy house?
Yeah.
I believe it.
Penelope gave me this because she missed my birthday.
That's very nice of Penelope. Let's show everybody what you get.
Okay.
Negative 3 to negative 5 is the opposite of negative 5 to negative 3. So this is positive 2. Go the other way. It'll be a negative 2. I get negative 12. That's a low starting point. And then let's go and find G of 4. I mean, I know it's not going to be G of 4, right? Look, I increase all this much. All of the accumulation of my derivative is how much we increase, and then I just decrease by a half. But whatever, let's do the work. I get 8 plus integral from negative 3 to 4. Did I find this? Why did I not find this? I did. Negative 3 to 4 is 6. So this is 12, 14, 14. Yeah, so obviously I start at the min. Yes! I increase a bunch to the max, and then I go down a little bit. All right, show everybody. What is it?
I don't know.
It's a hover bowling set. So that means that's like a hover thing that you can throw, slide on the floor and knock over the pins. That's going to be sick, dude.
Yay! Can I open it? Can you open the box?
No, I'm busy.
Come here, Ross.
But mommy's got you.
Wally, can you bring the wrapping paper this way?
This is actually cool because it's red.
We talked about how we could accumulate the derivative, but accumulating the derivative is very complicated because everything got shifted.
Mama,
Can you turn on a couple?
my favorite color is red and this is red.
Why? Can you turn on a couple more lights for me, bud?
Okay.
Thanks. It got dark.
I Okay, come here, Wells.
Guess what?
What? This
Did
is
you know
cool.
my favorite color is red and this is red?
It's super cool, kid. Let's go.
If I asked you for the max, the max is at 3. And I'd have to incorporate the area from -3 to 3, which would be 6 plus 4 minus what ends up being a -1. So that'd be 6 plus 6 plus 4, which is 16, minus 1, which is 15. And then I would drop down to 14. Yeah, it all makes sense. You could have accumulated your derivative. It would work out fine. But with this accumulation function plus, it's actually easier to just look at your candidates and look at the signs of your derivative to know what your candidates could be. F of 4, 16 plus 4, 4, that's easy. This is the graph of G. Okay, so this is 16. F of 2, 8 plus 4 to 2. I'm going backwards of G. Pay attention to all the letters. I flip things up on you so that you don't get used to doing the same thing all the time. 4 to, why did I say 4? What am I doing? I think I meant -4. I'll do it. So this is 4, and this is, so that's -4, and this is -2, because this is a slope of 1, this is base of 2, height of -2, so this is -2. So the total is -6. So going backwards would be +6. So it's 8 plus 6, which is 14. Opposite, subtract 2 to 4 of G. 2 to 4 is -6. The derivative is not this graph. The derivative is 4 plus G. Ooh. Which means you have to take G, shift everything up 4 units. This is like one of the examples we had. F prime of 6 would equal 4 plus G of 6. G of 6 is 0, but then we have a 4. F prime of 4 is 4 plus G of 4. G of 4 is -2, so this is 2. Hey, accumulation function with a boundary. What's the key? If you're finding a value, that's easy. If you're finding a derivative, it's harder. I would have to pretend like I couldn't accumulate. I would take the antiderivative to get big G. I'd get big G and I'd have to find its ending position, and I'd get big G and find its starting position and subtract them. If I took the derivative of this, I'd have regular G of 3x times 3. That's p prime of x, p prime of 2, therefore would be G of 6 times 3. That's 0. Okay, that's nice. What is the max value? This is great. Maybe if you shifted everything up 4, you'd be able to see it easily. Or if you are thinking about when does your derivative equal 0, that's when G equals -4. You could either think of this being your like new x-axis, or if you shifted everything up 4, G plus 4, you'd be able to see it's way up here, way up here. Hits there, there. It's positive or equal to 0 everywhere. G prime, which equals 4 plus, sorry. Keep messing this up. Okay. F prime, which equals 4 plus G, is positive until 2, and then positive after 2, which means F is increasing and increasing. You got to write this out. This is not worth anything. You'd have to say f prime is greater than or equal to 0 from 0 to 7, which means where is your max at 7? (28) plus the accumulation of g from 4 to 7 going back to the original equation from 4. Why did I say 7? It should be 6. Oops. Sorry. Six times 4 is 24. 4 to 6 is negative 2. Base 2 divided by negative 2. So 22. 22 is bigger than 16, which is bigger than 4. Yep, it wins. Cool. Couple more. All right, x plus the accumulation of m. This is the graph of m. This is not the graph of the derivative, unfortunately, because the derivative is 1 plus m. You have to write that down. N of 3 is 3 plus the accumulation from 0 to 3 of m. 0 to 3. Why did I do that? I think I'm telling you why in a second. This is not a whole number. We got to find that value. This was an actual problem in an AP exam. This is a tricky problem. 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay. So the slope of this line is negative 2, which is down 2 over 1. Or down 1 over a half. This is the point 1, this is the point 0, 3, this is the point 1.5, 0, this is the point 2, negative 1, this is the point 3, negative 3. Okay? So, 0 to 1, 2, 3 incorporates this triangle, 1/2 base of 1.5, height of 1, 2, 3. Why? Why do they do this? I mean, like, calculus is hard enough. Why do we have to be tricky like this? 9/4. I think I gave you this on the test. Then, from here to here, this is a 1/2 base of, again, 1.5, height of negative 3. Oh, okay, so that's going to be negative 9/4. Cool. So that's just 3. It's kind of like a trick there. Okay, I see what you're doing. N of negative 4. Oh, great. Probably should have told you this is a quarter circle and this is a quarter circle. This is a quarter circle radius 3, so this is a quarter of a pi times 3 squared, which is 9/4 pi. This is a quarter of a circle radius 1, so this is a quarter of pi. Okay, so I got negative 4 plus accumulate m from 0 to negative 4. It's the opposite of negative 4 to 0. So that's a negative becomes a positive. That's a positive becomes a negative. Play it in the kitchen, Wally, on the floor. It'll hover better.
Yes.
Great. It turns on.
Yeah, watch. Look.
Ollie, come here.
Let me see. Show the students. Oh, it's hovering. It's like a Roomba, only it's just to play with.
Yeah, you did.
It's like a big like hockey puck. Have we played air hockey yet as a human being?
No.
You haven't played air hockey yet? That's like a big air hockey puck.
Yeah.
Cool. So you can set up the bowling balls and
You turn it on, then you move it where the bowling ball.
yeah, and then you try to slide it across the floor. Cool, Bugs. Well, that's actually cool. That's a good present. All right. N prime of 1. 1 plus m of 1. M of 1 is 1 plus 1 is 2. N prime of negative 3 is 1 plus m of negative 3. Because I know what the derivative is, I wrote it down earlier. M of negative 3 is 0, so that's just 1. Let's go straight to the min of n. Oh, gosh. Okay, this is probably a good idea of like, when is it beneficial to shift? When is it beneficial to use a line? Because actually, in some cases, one's probably better than the other. I don't want to shift this stuff. Mainly because, like, I got to figure out how to shift this. Now, we wrote this down earlier. This is the point 2, negative 1. N prime equals 1 plus m equaling 0 is when m equals negative 1. Yo, your candidate is 2. I'm changing this to max because I want you to find it. Now, if you think about it being bigger than that value, that's like your derivative 1 plus m being positive. Negative would be 1 plus m being negative, or like below it. So n prime, which equals 1 plus m, is positive until 2 and then negative after that. Okay? So we know that has to be the max. Two plus, well, also 2 plus the integral from 0 to 2 of m. Yeah, this is like so tricky. This area right here is a half by a half by negative 1. It's negative a quarter. Nine fourths minus a fourth, which is 8 fourths, which is 2. That's going to be your max. Why? Because n prime is positive from negative 4 to 2, and then n prime is negative from 2 to 3. And then if we have now my ear's freezing. Accumulation function with that in. We already did that. It's just going to be the negative 2 pi. The derivative of w will be m composed of 2x times 2. There you go. I'm going to pause. Talk to grandma. Plug in the computer. Back. I was sitting on my hat the entire time. I wear a hat in my normal life. All right. Half a circle. Slope. Negative a half. I'm not going to put unnecessary information down. Let's just go for it. Yo, my bad. I meant this to be x. Sorry. It's the graph of w. M of negative 1 is negative 1. M of 1 is 1 plus negative 1 over 1. This is half of pi. Why is it half of pi? Because it's pi times r squared divided by 2. It's a negative half of pi. Okay, m prime is 1 plus w. If you did this problem normally, you'd see that like all that is like all the values are shifted up 1. But this is the graph of m prime. But if we go to what I originally intended, m prime is 1 plus w. I wish it was negative 1. But then those areas would have been too tough. So m prime of negative 2 would be 1 plus w of negative 2. W of negative 2 is 3, so this is 4. M prime of 1 would be 1 plus w of 1. W of 1 is 0, so this is 1. Max value. All right. Again, if we shifted everything up 1, I'm glad I'm just showing you this on your homework because it shows up on your test something, I think, similar to this. M prime, which equals 1 plus w, is bigger. Like w is greater than negative 1, which means 1 plus w is greater than or equal to 0 for all x's from negative 4 to 3. Just say for all x's. So that means m of 3 has to be the max, right? If m prime is positive or 0, it just is going to increase, which means the furthest point at the end is going to be the max. Three plus integral from negative 1 to 3. So that's 3 plus negative pi over 2 plus negative 1. If you're not picking up the, hey, make life easy on yourself with maxes and mins, that's fine, guys. It's more work on you. If you want to keep doing Max is when the derivative equals 0 at endpoint, like we did last unit. That's safe. That always works. If you want to be able to adjust and make it so it's easier for you, do that. R2 is 1 to negative 4 of W. 1 to negative 4, which means that would be a positive pi over 2. This is 1/2 base of 1 height of 3, 3/2. This is a rectangle of 2. This is a triangle of 2. 4, this is 5.5 total. So I would add the pi over 2. I would subtract the 5.5 or 9/2. R prime is more complicated than you think it is. If you took the accumulation and instead of accumulated, you said, okay, I can take an antiderivative, right? I can use capital W ending minus capital W starting. When you take the derivative of that, you get regular W of the inside times the derivative of the inside. R prime of 2 equals W of negative 4 times negative 4. W of negative 4 is the y value, which is 1 times negative 4, which is negative 4. All right, here's a free response question. Combines day 2, day 3. It's a good practice for the test. Your review for your test is just might put together like a free response sampling. But here's some. Here's part of your test review. Find f of 0, find f of 5. Okay, right now f is equal to the accumulated area of g. This is the graph of g. Well, I already know that that's the graph of the derivative because it's not an accumulation plus. It's just the derivative of an integral. Okay, so that's good. F of 0 is the integral from 4 to 0. Show your work. 4 to 0 is the opposite of 0 to 4. This is a semicircle radius 2, so that's pi times 4 halved. So that's negative 2 pi in here. Pi times r squared halved. And then here I got triangle base 2, height 2, and then I have a triangle above a rectangle, that's the 1.5. So from 4 to 0 is going to be the opposite of 0 to 4, positive 2 pi. Don't mess up on that. F of 5, what? Sure. 4 to 5 of g. Okay, so 4 to 5 of g. I have to understand my slope. That's a slope of 1. This is a triangle base of 1, height of 1, so that's a half. Find the x-coordinates of all points of inflection of the graph 0 to 7. Justify your answer. Okay, so f's second derivative, which is g's first derivative, will tell us when f prime equals g increases or decreases, which will tell us if f is concave up or concave down. This is what I always put down, just like, I don't have to put it down, but you should. You should always put this down just so you understand. Okay. Points of inflection when concavity changes is when the slopes of g change sign or when g changes direction from increasing to decreasing or decreasing to decreasing. So when does it slopes change sign at 2, negative slopes to positive slopes, or we go from down to up at 2. We go from up to down at 6. X equals 2, x equals 6. Yeah, this was a free response question from last year, actually. This is last year's, or 2 years ago, free response question. H is f minus x. At what intervals is h decreasing? It's beautiful. All right, well, so h is going to go down when h's derivative is negative. H's derivative is f's derivative minus 1. F's derivative is g minus 1. H prime is g minus 1. Okay. When is g minus 1 negative? That's when h is decreasing. Now, g minus 1 being negative, maybe you want to, in this case, shift, go down 1 on everything, hit 5 as your major point. 5 is your major point. Guess what? They asked you to find f of 5. It's for a reason. From 0 to 5, because because h prime, which equals f prime minus 1, is negative. Um, Another thing you could have done is found when um, g equals negative 1. Sorry, g equals positive 1. Again, you find when your derivative equals 0. That's when g minus 1 equals 0. That's when g equals 1. So you could have said, when does this equal positive 1? I don't know. I think, like, again, you're ready to adjust and adapt, shifting or new axis. I actually think that shifting is okay in this one. Sometimes it's not okay. It's not easy. Yep. For the function h to find part c, find the absolute minimum. Okay. So there's one answer. H prime, which equals g minus 1, if I still have the graphed, is negative until 5, then positive from 5 to 7. H prime is negative from 0 to 5. H prime is positive from 5 to 7. G of 5, which equals, sorry, H of 5, which equals f of 5 minus 5, must be the min. We found f of 5 earlier. They asked you to find it. This was y, a half. It's for response. You don't have to simplify. Yo, and I throw out a rates again. This was from like last year, and that previous problem was from last year, and I didn't put them on the previous homework. So this is just like good problems. We got people entering a line, and then people exiting the line. We got a rate in. We got a rate out. We got an initial amount. This is a classic. We got a calculator. How many people enter the line? All right. Well, I always like to write this down. We're back to t's. Back to t's, guys. Time rather than x's. My total amount is my initial amount plus my total in minus my total out, which means my derivative is r minus 0.7, which means my total amount can also be 20 plus the accumulation of p's derivative, which is a combination of r minus 0.7. It's not 0.7x, it's just 0.7. You accumulate 0.7. It's 0.7 times t would be the total accumulation. Regardless, total in would be the accumulation of r. So I would accumulate r from 0 to 300. This is when we want to get our y1, y2s, 44, t over 100, cubed, 1 minus, use the fraction button, guys. It's there. We don't want to make mistakes with parentheses to the sevenths. That's the rate in. The rate out is 0.7. Got rate in minus rate out as my derivative. Going to graph my derivative. From 0 to 300. Why? Because I can. Zoom fit. There's a min. There's a max. I think this accumulation is bigger than that accumulation, but it's not super seeable. So if I were to ask for like the maximum amount of people online, I probably would check my candidates. Just being honest with you right now. But we wanted to accumulate from 0 to 300 R Y1. That's nice. Who would have thought? People, I think they don't like getting non-whole number answers. At t equals 100, are the amount of people in line increasing or decreasing by how much? This is like when you look at the rate in versus the rate out. You want to look at all three graphs at the same time. Or you just look at p prime at when? 7? Is that really 7? No, 100. This is the y value of p prime. The value of p prime tells us how quickly p is increasing or decreasing. P prime, and I wrote down that p prime is r minus 7 at 100 equals 1.875. Remember, x v a, f prime, f double prime, p prime, p double prime. P prime is a velocity. In this case, it's people per second, persons per second, persons per second per second. Like the units should help you understand what you have. So this is persons per second. Total people in line is increasing by 1.875 people per second. How many people are in line at t equals 300? That's easy. Yo, how many different ways do you want to find it? Well, here's one way. Here's another way. You want another way? Step it out, with all of the zeros and stuff. It's like I got to do the absolute max anyways, Mr. Mester. So might as well just like do all the steps and do my entire sign analysis while I'm here. Might as well find this A, find this B, go from there. But I'm not going to do that. That was my total in. Add 20 to it and subtract 0.7 times 300, or the accumulation of 0.7. 80, or you could do 20 plus your accumulation of p prime. P prime was y3. $80. Okay. It's like easy to do either way. When is it hard to do this way is when the R's, the rates in and the rates out change. And if the rates in, rates out change, you need different P primes for different intervals, which creates Y5s and Y6s. It's probably easier to just accumulate them separately. When is the first time where there's no people in line for the escalators? So people stop entering the escalators line at the 300th second. So the rate in just like goes away. So it's really like, how long will it take for our accumulation of our rate out to equal 80? Now, like you could say 0.7 people per second times seconds, and then divide that by 80, and it's not going to be the time. This is like how many extra seconds we need. So it's almost like you want to do like t minus 300, so that it's like after the 300th second, I'll find the second. This is kind of like the idea that you would have to come up with. There's other things to do, but I'm not going to talk about it until later units where you can use a variable in the integral. Honestly, you could. It would be 114 more seconds after the 300th second. So it would be 414 seconds. This is just a good, challenging question. I mean, I guess they want specifics, so 0.285. Okay, now they find the min. Shucks. All right, P. And I'm literally doing candidates because I don't see an easier way besides looking at the accumulations and then writing a whole lot. There isn't just one candidate, there's a bunch. Honestly, it's easy enough to just write the candidates. P is a min when P prime equals 0 or an endpoint. I got P of 0 equals 20. I got P of 300, which is 80. I got an A and a B. I got to write them down. I got to find them. I got to accumulate them. Let's throw in Y equals 0. This is the graph of my velocity. Second, calc, intersect, enter. That's my B. Switch to your Y equals 0. It might be easier to slide over. There's my A. Got to write them down. A is 33.013. If I write it down once, I don't have to write it down again. B is 166.574. All right, so we got P of A, which equals P of 0. We'll step this out, plus the integral from 0 to A of P prime, or separating, and then P of B. I'll use P of A and step this out. I've never used this concept, step this out. Use one interval at a time. Okay, 20. Let's find the integral. Beauty. 20 plus integral from 0 to A. That's a relative min, right? Ooh, got close to no people. Good job, test makers. But then I don't know about the endpoint. Well, actually, the endpoint. Yeah, okay. So we increase by a lot between A and B. The area between A and B is more than this area that we decrease and that area that we decrease combined. So P of A plus my integral from A to B of y3. Yeah, we got a winner. Good to do this, like min by candidates test. Don't forget, where do my candidates come from? If it's general like this, there's probably going to be a lot of candidates and you have to check all of them. If you'd like to try to get more specific, or if you'd like to not have to show all of your candidates, you can change this to be like, oh, I have to have a max because of this. Typically, we want to change this when we know where the max is. I mean, I'm sorry. We could have been a little bit better. We could say P is a min when P prime changes sign from negative to positive, or an endpoint. And like, I don't know why we'd have to worry about this. It wasn't that much extra work, but if we wrote that, we eliminate B. We didn't have to check B. We just had to check here. We didn't even have to check 20, but like we have to write a statement why we're excluding checking that endpoint, and we already have it, so it's no big deal. So yeah, it's up to you. But like, I'm hoping you understood from these 3 lessons that Unit 8 is just Unit 7. It just looks different. Okay, so hopefully we get this, and I will be seeing you guys. I feel like I got a little sunburned today. I'll be seeing you guys on Wednesday. Hopefully with medicine for my throbbing sinuses. All right, later.